Hi there. Question 13. Which of the following compounds does not have an isomer? Well, you might be able to spot this answer immediately in that it's ethene, because ethene is just a little tiny molecule like that. I'll show you in the data book. So this tells you how many carbons are in each one. So methane has got 1 carbon, ethane has got 2 carbons, propane has got 3 carbons, and so on. Whereas this is ethene, and it's got that ene ending, it's got a double bond. So ethene will be this little tiny molecule with a double bond. And isomer means that it's got the same formula but a different structure. And that's just too small to have the same formula and a different structure. But if you have a look at these other ones, you'll see that they do have isomers. Right, cyclopropane. If we have a look here, prop, that's the third one down, so it will have 3 carbons, and it's cyclo, so it will be in a circle. With 4 bonds around every carbon. But you could also, so that's C3, H, 1, 2, 3, 4, 5, 6, 6. But for the same general formula there, is it called general formula? Molecular formula. For the same molecular formula, draw that a bit better, 6. You could have something like that. Which would also be C3, H6, 1, 2, 3, 4, 5, 6. And butene, that has an isomer. You could have butene. I didn't mean to draw that. This is but1ene because it's got a double bond on the first carbon. And I'll just do the little hydrogens round. But you could also have but2ene, and that would be an isomer. But2ene would look like that. Sure, I can draw this eventually. And pentane. Pentane can have different shapes. Pent is for 5, and I'll show it here. 1, 2, 3, 4, 5. So pentane has 5 carbons. 1, 2, 3, 4, 5, which would have little hydrogens around it. Or you could have it in a slightly different shape. That would be butane 2. That would be 2 methyl butane. I'll just show you. So butane is the 4 carbon chain, and the little methyl would be the one sticking off to the side. But that would have the same molecular formula because it would have the same number of carbons and the same number of hydrogens. So after all that, the answer is ethene. The systematic name for this thing here is, and then you have to choose. So I shall just do it one bit at a time. So I shall start with this bit, the CH3, and then I shall do this bit, CH2, and then I shall do this bit just to see, and then I shall do this bit, which is a branch off to the side. You can tell it's a branch off to the side because it's in brackets. And then I'll do this bit, which is a CH. And then I shall do this bit, which is a CH3. And now I'll just count the number of bonds around each carbon. So that's 4, but that's 3, and that's 3. So there needs to be a double bond in here so that we have 4 bonds around each carbon, and the rest have 4, which is fine. So we're looking for something, 1, 2, 3, 4, 5, something that has pent in it, and it has a 2-ene, because if I just number the carbons, there's a double bond on the second carbon, so it must end pent 2-ene. So it's going to have to be this one, because it ends in pent 2-ene. And it has a little methyl group on its third carbon, so that bit's right as well. Question 15. When pent 1-ene undergoes an addition reaction with water, 2 products are formed. Which of the following alkenes will also produce 2 products when it undergoes a reaction with water? Well, some of these won't produce 2 products because they're symmetrical. But this first one, oct-2-ene, that's not symmetrical. Let me show you what I mean. So oct stands for 8, so there are 8 carbons. 1, 2, 3, 4, 5, 6, 7, 8. And on the second carbon we have a double bond. Let's put in the hydrogens. So water could add itself on here with a little, you could have an OH added on here and an H added on here, or you could have an OH added on here and an H added on here. So there are 2 different ways that that double bond could break, and those OHs could be added on. Just put the, yeah, that's fine now. So this is definitely the answer, but why are these other ones wrong? And the answer is because they're symmetrical. Let me draw hex 3-ene. Hex is for 6, I think. Is it? So just check. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And on the third carbon there is a double bond. And you can see the symmetry there. So this time, if I added an OH here and an H here for the water, and then the whole thing just rotated round, it would be exactly the same, except the OH and the H would be on the other sides. And so it doesn't really matter where I put the, where the water molecule joins on, whether it's OH here or an H here, with that bond being broken, it wouldn't really matter. Because I should put the double bond back in. because the double bond is in the middle. And but-2-ene, that's another one where the double bond is in the middle. And ethene, double bond in the middle. Oops. So the answer to 15 is A. Thanks for watching. Bye.